Hey, Lily.
Hi, Miss Sparks.
How are you, honey?
Good, how are you?
Good. Um, did you put your packet in order?
Oh, well, I had to reprint it because I couldn't find the packet that we were using in class.
Yeah. So is it in order and did you number them?
This doesn't look numbered, and I don't think it's in order.
You
Sorry, I think
don't
my
think
mom reprinted it or something.
Okay, this is actually page 24 that's up on the screen right now.
Oh, okay.
Because I had somebody else ask some questions too that was absent. So, so I'm so I was actually working some while I was okay, so your mom reprinted. I just got your email.
Yeah,
Um,
I saw it right after I sent the email.
oh, okay. Okay. Yeah, your mom had emailed me and told me that she had reprinted it for you. So, there's like I worked a few pages and was sending them to somebody else. I worked 14, 15, 23, and I'm working 24 right now. So I thought if we could get through some of the beginning parts, I'll just send you pictures of these worked out. I worked out the substitution and the elimination, but I didn't work out the graphing on those just just because I would have to. I can probably try to do it on here, which you'll be able to see, but the some of them it's pretty precise where they intersect.
Uh-huh.
So when you're trying to hand draw them yourself, they don't come out right. You really need the graph paper.
Yeah.
So, but we'll start at the beginning. Let me just finish this one up real quick. Um, and then we'll get going on the packet. So, did you try to work number one by yourself?
Not yet, but we did that one in class.
Yes.
Redone it.
Okay. And like I say, I did work all of these out, so I'll get them sent to you too.
Okay, thank you.
Uh huh. All right.
Whew.
And if okay, whoops, I always forget that you have to be in a certain mode to make this one move.
Ugh.
You can see where I've already written on this packet before. Hmm. There's a little pop-up window that's not letting me see what page number, but this is the first page, right?
Yes, ma'am.
Okay. So for substitution, what you're going to do is substitute in for y, because this is telling us what y equals. and here's a y. So you'll substitute for y this value right there, which is negative x plus 2 equals 12. So then you'll distribute. So you've got 3x plus a negative 3x plus 2 equals 12. And so that actually cancels out, and then you've got 2 equals 12. Well, that doesn't equal each other, so it's no solution.
Wouldn't you distribute the 3 to the 2?
Oh, yes, you're right. I didn't. Good catch. Good job. So it's actually 6 equals 2. A 6 equals 12, which doesn't equal 12, so it's no solution. So you don't, once you get a no solution like that, either in substitution or elimination, you don't have to do the substituting for the other part. But for elimination, what you would want to do is this is in y equals negative x plus 2 in that format. So you're going to add x to both sides. And then that would give you x plus y equals 2. And then 3x plus 3y equals 12. And so what you would do is you would multiply this top one. I think what I may have to do is erase this so that I can come back up here after I get done doing that.
Thank you, Kelly.
Oh, hey, no problem. How are you, Michelle?
Good. I just walked in. We will pay you in whatever you want. Cash, truffle, gift cards, combinations, the one giant gift basket. Thank you so much. And I'm so sorry we're still on this, but honest to goodness, this makeup week was a doozy. But that you've been so gracious. This is our last thing. So we thank you so much.
Oh, no problem. No problem.
All right. I'll let y'all get back to it.
She's really doing good on this stuff, though.
Good. I don't know why she acts like it's hard.
Confused.
You're confused. All right.
Okay, so you'll multiply this one by 3. Okay. In order to actually a negative 3 would be even better. So what I'm going to do, Lily, is I'm going to go up here. So negative 3 times x is what?
Negative 3x.
That's right. And then negative 3 times y is?
Negative 3y.
Good job. And negative 3 times 2 is what?
Negative 6.
Good job. So then I'm going to just copy this second one down underneath it. And with elimination on this one, everything cancels. And you would actually get 0 equals 6, which is not a true statement. So for elimination, you've also proven that there's no solution. Okay. And then, you know, as far as graphing, you would just put it in, you know, y equals x format and then graph it. And they're going to come up to be parallel lines. I'm sorry?
So you wouldn't multiply the 3x plus 3y equals 12 by 3?
You mean for elimination?
Yes.
No, because the whole point of elimination is trying to make 2 of the coefficients the same or opposites. So they'll eliminate. So if I would have multiplied this bottom one by 3 also, that would have made it a 9. You see what I'm saying? See, the coefficients are the same now so that they're going to eliminate.
Oh, okay.
That's where they come up with that word. Elimination. Does that make sense? The whole point is to eliminate, which starting the whole packet with a no solution one doesn't make quite as much sense on the elimination, but that's what you would do. Are you good with the graphing?
I'm a little fuzzy on it, but
okay. So let me graph these then. And I feel like this one might have been off. I can't remember if it was off the charts. Okay, the first one's already in y equals mx plus b format. So you're going to look for your y-intercept. So here's your y-intercept, and it doesn't work real well on this for whatever reason. That's your y-intercept right there. So now you've got a -1 slope. So I have to go one direction positive and one direction negative. So if I go up one, I'd go left one. If I go down one, I would go right one. Like that. Okay. And it's not going to be real pretty. Sorry. And then this one, the 3x plus this one, I would have to put in slope intercept form. So I'm going to subtract 3x from both sides. And that leaves me 3y equals -3x plus 12. And then divide everything by 3. And I would have y equals -x plus 4. So 1, 2, 3, 4. And once again, the line would look like that, and they're parallel. Okay?
Okay.
All right. Do you want me to move on, or you want to look at it a little bit more? Are you finishing up? I'll give you a minute.
I think I get it.
Okay.
I just got confused when you did the how you did the 3x plus 3y, like how you got to graph that. That kind of confused.
How I got to graph it? I put it in slope intercept form. That was confusing?
Yes, that was it.
Okay.
Now I understand what you did. So.
Oh, okay. All right. Let me know when you're ready for me to move it up.
I'm ready.
Okay. All right. So on this one, in substitution, I've got a y equals. So, and it's telling me that it's 3x plus 2. So wherever there's a y, I would plug in 3x plus 2 equals -8. Do you see that?
Yes, ma'am.
Okay. So now I'm going to combine like terms. So there's a 2x and a 3x. And when I put those together, that's 5x plus 2 equals -8. I need to subtract 2 from both sides.
And then you would get a -10.
Yes, ma'am. And then I'm going to divide 5, both sides by 5. And that's going to give me x equals -2. And then I'll take that -2 and I'm going to plug it back in to that first equation. So I would put y equals 3 times -2 plus 2. And then that would give me y equals -6 plus 2.
Oh, it would be -4.
And then y equals -4.
You don't have to graph that, right?
What do you mean?
Like if you do solve by substitution, you don't have to put it on a graph.
No, you have to do it all 3 ways. It was to give you practice, because see, every single problem you were supposed to do by substitution, elimination, and graphing to basically give you lots of practice for doing substitution, elimination, and graphing. So once you got your point, you would put it up here. So now you've done it by substitution. And then you would do it by elimination, and then you would do it by graphing.
Okay.
So you tell me what we need to do to graph this.
You would go down 4, like -4.
Well, you graph the line. So you have to use the equations to graph it.
Oh, okay.
Yes.
I thought we were using the
So Now, if you wanted to, Lily, I really am okay with this. If you wanted to, it doesn't really prove the complete point of how they intersect by graphing, but actually, if you wanted to, like this one, y equals negative 2x minus 8 is the other, like this is this line in slope intercept form. Do you see that?
Uh-huh.
I'm sorry?
Uh-huh.
Okay. So if you wanted to go down 2, left 4, 1, 2, 3, 4, and then use the slope here and the slope here to graph both of your lines. Do you understand what I mean by that? Like this slope is 3. So I would go up 1, 2, 3 and right 1.
Uh-huh.
Or down 1, 2, 3 and left 1. So there's one of my lines. And then if I use that same point, but use my negative 2 slope, down 2, left 1, up 2, right 1. They're really close together.
For what I did solve by graphing, I got y equals 4x minus 8.
How? Because you put this in slope intercept form.
Uh-huh. Y equals 2.
So, and then you graph this one, and it's already in slope intercept form. So it's actually going to cross right there, and that's how you do it.
Okay.
So this is the point, and the point where they intersect is the solution to the problem. Does that make sense?
Kind of.
Okay. You put them both in slope intercept form.
Uh-huh.
Okay, let's just erase it and do it that way. Okay, you agree with me that this is in slope intercept form?
Yes.
Okay, so let's just graph that one. So I would go up 2 for my y-intercept, right?
Uh-huh.
And then now what I'm going to do is go down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Maybe I didn't even get my... Hold on just 1 second. Oh, I didn't go up far enough. I got to start over. I only went up 2. That's where I was supposed to. One, 2, 3, left 1. 1, 2, 3, left 1. Okay. So I'm graphing that one. You agree?
Yes, ma'am.
I've used slope intercept form. I'm trying to draw a straight line. That's that first line in slope intercept form. Now this second line right here, y equals negative 2x minus 8. I put it in slope intercept form, right? Does that make sense to you?
Yes.
Okay, you see where I get it?
Yes.
Okay. Are you positive?
I think so, yes, ma'am.
Okay. So what's my y-intercept?
Negative 8.
Good job. 1, 2, 3, 4, 5, 6, 7, 8. It's way, way, way down here. And then I've got a negative 2 as my slope. So if I'm going to go up 2, left 1.
Uh-huh.
Up 2, left 1. So that's going to be the other one, the other line. Okay?
Uh-huh.
Does that make sense?
Yes, ma'am.
So where did they intersect? Where is that?
I get confused with finding the point of intersection. That's where I'm most confused.
Oh, okay. Where the two lines cross,
Uh-huh.
you can't really tell where they're crossing. Is that what you're saying?
Like, I see where the cross is, but I don't know, like, what the numbers are.
Okay. Okay. Let's see. On the x-axis, how far over did you go?
1, and then I went down 1.
How
Or you
far?
mean where the cross is. Okay.
Okay.
Well, I did over 3, and then I went down, no, over 2, and then
Yeah.
I went down 1, 2, 3.
One more.
4.
Counting? Yes. Wouldn't you say this is at 1, 2, 3, 4? Do you see that in pink on the screen?
Yes, ma'am.
Do you see where that is?
Uh-huh.
So that's 2, -4, right?
Mm-hmm.
So the point of intersection where you're graphing it was the same thing that we came up with substitution.
Yeah.
So the two lines cross where when we solved it by substitution, it was -2, -4. And this point is -2, -4.
Mm-hmm.
Does that make sense?
Yes, ma'am.
Okay, but you just get confused in counting it?
Yeah, I think I understand it now.
Okay. All right. Sometimes it can be a little difficult, when you get a lot of mess on there like that. I see where you're saying. So the best thing to do is maybe, just kind of take your time and start from the origin and get the best, line to be able to guess it.
Uh-huh.
Or maybe even do them in different colors or something. Kind of like I did here to help.
Mm-hmm.
All right. So for elimination, the only reason I'm erasing that is because when I move the screen up, the lines are going to be wrong anyway, and I don't want that to confuse you. And I'm going to have to move it up to get to that elimination box. For elimination, we've got y equals 3x plus 2. And then 2x plus y equals -8. So what I'm going to do is I'm going to take this line right here, and I'm going to bring my 3x over. Just going to erase that. Because I'm trying to get it where my x's and y's line up.
Uh-huh.
Right? So I'm going to subtract 3x. So it's going to give me 3x plus y equals 2. Okay?
Wouldn't it be a -3x?
Yes. Sorry. Good job. So -3x plus y equals 2. And then we've got 2x plus y equals -8. Now, are there two coefficients that are the same or opposite? What is the understood coefficient on that y?
Positive?
Yes. But what's the number?
1.
Yes. And they're both a 1. So they're the same, right?
Uh-huh.
Okay, so they're both the same. And if they're both the same, you subtract. So what I'm going to do is subtract this whole line. So I put it in parentheses to remind me that I have to distribute this subtraction sign all the way across, okay?
Oh.
So negative 3x minus 2x is what?
Negative 5x.
Yes. And y minus y is going to cancel just like we wanted to. We're looking to eliminate one of the two variables. So y minus y gives us a 0. So we've actually eliminated it, just like our goal, what our goal was. Now, 2 minus a minus 8 is what?
Minus 10.
10. Good job. So then you have, now I have negative 5x equals 10. Did you see where I got that?
Uh-huh.
Okay. So I'm going to divide both sides by 5. And x equals negative 2. And then you would plug that back in to one of the equations, and it doesn't matter which one. So y equals 3 times negative 2 plus 2. Y equals negative 6 plus 2. Y equals negative 4. So I've worked it all three ways: graphing, substitution, and elimination. And I got consistently negative 2 and negative 4. The whole point behind the packet was it was self-assessing, so that once you did it by substitution, if you didn't get the same points for all three ways, then you knew you did something wrong and you were supposed to go back and correct it.
Uh-huh.
So you ready for me to move to the next one?
Yes, ma'am. Thank you.
Uh-huh. All right, this one. We could solve by graphing first if you want to. Do you want to?
Sure.
Okay. So this one's already in slope intercept form, so I'm going to go ahead and graph it by default. What's my y-intercept?
Negative 1.
Yes, ma'am. Good job. What's my slope?
Negative 2x.
Yes. So if since it's negative, I have to move one direction positive and one direction negative. So if I go up 2, I need to go left 1. But if I go down 2, I have to go right 1. So
Okay.
there's my line on that one. It kind of moved on me. This one, the x plus y equals 2, I need to put it in slope intercept form.
Uh-huh.
So I'm going to subtract an x from both sides, and that would give me negative x plus 2. So this line's bothering me. So on this one right here, what's my y-intercept?
Positive 2.
Correct. Good job. What's my slope?
Negative x.
Yeah, -1. It's just the coefficient that's on the x that's the slope. It's just the coefficient. So m actually equals -1. So if I go in one positive direction, I have to go in one negative direction. So they intersect right here. Can you count that for me? Whoops. I think I messed something up. Hang on just a second, Lily. I messed one of my lines up. Ugh. There we go. I think I'm getting it. Trying to get my lines straight while I draw on this screen is not always easy. Now, what is that line? How far over did I go from here?
3.
Yes. And how far up did I go?
5.
Yes. So the point I'm looking for is -3, 5. So now when I work it by substitution, I should get that same point. So this is what y equals. So I'm going to plug that in. So I've got x plus -2x minus 1 equals 2. So x plus a -2x is what?
-3x.
Well, this is x. So that's a positive x plus a -2x. Yes, ma'am. -x minus 1 equals 2. So I'm going to add 1 to both sides. Yes?
Yes, ma'am.
And -x equals 3.
So
then you can't have a negative. So what do I do?
X equals -3.
Yes, x equals -3. And then you take that -3 and substitute it in to that bottom equation. So y equals -2 times -3 minus 1. Y equals 6 minus 1. And y equals 5. So with substitution, I got -3, 5. And that's what you're trying to do. You're trying to make sure that you get the same you get the same point all 3 times in the packet because it teaches you how to do every type of the equation or every type of solving for systems of equations. So for elimination, what would I do on this one? You want to get your X's and Y's lined up. So what could I do?
You could subtract the y on the second equation.
Subtract the y? This one?
Yes, ma'am.
And yes, you could, but wouldn't it be easier to bring this one over here?
Oh, yeah.
Okay. So you'd have 2x because instead of subtracting, I'm going to add 2x to both sides, yes?
Yes, ma'am.
Okay, so 2x like that. So that's going to give me 2x plus y equals -1.
And then you would subtract them because they're the same.
Well, you would, good job. X, good job, Lily. X plus y equals 2. And they are. The y's are the same, aren't they?
Uh-huh.
They both have a 1, so you would subtract them. So 2x minus x gives you x. This would eliminate, right?
Mm-hmm.
And then -1 minus 2 equals -3, which that matches everything that we've done. Then I would plug that -3. You can use it in either one of the equations that you want. And, you obviously, since we did this one before, for simplicity's sake, you actually could draw an arrow up to it. I'm fine with that if you want to. 6 minus 1, and then y equals 5. But even with elimination, you got the same exact thing.
Uh-huh.
So that's what you do.
Thank you.
Uh-huh. Do you want me to do a few more with you?
Sure. Thank you so much.
Oh, no problem. And then, like I say, I worked out 14, 15, 23, 24, and I'm going to be working out 25 because that was one more question, because you're not the only one that's still trying to make up sick work.
Okay.
Yeah, you're not. Yours was more fun than everybody else's. You were having fun. They were not having fun. But so this is what is this? Page 4? Is that right?
Yes, ma'am.
Okay. All right. On this one, let's just solve by substitution first. So this tells me that y equals x plus 4. So wherever there's a y, I will stick that in. So 2x minus x is x plus 4 equals 3.
Wouldn't it be a -4?
Oh, yes, good job. Way to go, Lily. Because you distribute that negative all the way through.
Mm-hmm.
Good job. Okay, so now I'm going to add 4 to both sides. And I've got x equals 7. And now I'll substitute 7 back into the equation. And I've got y equals 7 plus 4. Y equals 11. So 7, 11, which that's off the graph. And what I've been telling others about when they're off the graph like that, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've been telling them, go ahead and make your dot way up there. And then when you graph those, just show when you graph both of those lines, like this one is going to be here. Just show it going up that way. That's what I've been telling everybody with ones like that. Okay? Because the literally is intersecting way out here.
Uh-huh.
So that's what I've been suggesting that they do. And so for a lot of them, what people started doing was go ahead and solving them by elimination and substitution first to try and get the point and make sure they can confirm by doing it both ways that they got whatever the point was each time. And then they would go into their slope intercept form and graph their lines and make sure that the lines went up in the direction of the intersecting point. Does that make sense?
Kind of.
Okay. All right. Well, this one that I just graphed was the y equals x plus 4. So let me go ahead and put this one in slope intercept, which that's going to be negative y equals negative 2x plus 3. And then to get the negative y off, I'm going to have y equals 2x minus 3. So my y-intercept is negative 3 and my slope is 2.
I have a question.
Yes,
On
ma'am.
the last one, when I was solving for substitution, I got negative 11. And I got the same answer when I did for elimination.
On this one?
For the 2x minus y equals 3.
Okay.
Because I plugged in the 7. And then wouldn't you subtract the 14 from the 3?
Okay, let me take
Oh, you divided it by a negative y. Okay, I understand now.
Okay.
Okay, that makes sense.
All right. So when you're graphing these, just go ahead and use your point slope formula and make sure that you're headed toward this point right there. But confirm that you get it with both substitution and elimination first. So you're already working on elimination on this one?
Yeah, I got that one and I got the same answer.
You did get the same answer? Okay, good.
I'm just confused on how to do the graphing for this one.
Okay. All right. You see, I put this one right here is the green line. And there is you just basically, do you understand where I took the point that we got, which is 711, and I counted right 7 over 7, and I went up about 11 and created a point, and I just made sure when I used the point slope formula for the rest of these that I went toward that line. You see what I'm saying? That point. You still are graphing them the exact same way that we've been graphing them. It's just you make sure that your line goes toward that point of intersection. We determined that this is the solution to the system. It's where they're going to intersect because the solution to a system of equations is the point at which the two lines intersect. So once I start graphing them using the point slope formula, which we've been doing, they should intersect at that point.
Uh-huh.
So you'll still, like this line, the y equals x plus 4, what is the y-intercept? For y, this one.
4.
Yes, see? So I graphed the 4. It's right there. Right here. And then what's the slope?
X, which would be 1.
Yes. So I went over 1, up 1, over 1, up 1, over 1, up 1. And I did a good enough line it kind of came off the thing, but my line went toward the intersection. Does that make sense? What I'm saying is you still draw it the same way you normally, but I just made sure that I went up toward that point of intersection that we determined as 7-11.
Uh-huh.
Does that make sense?
A little bit. My graph kind of looked different because I went for the X. I went over 7 to the right and then up 11.
Why did you? For what? Yes.
For solving by graphing.
Solving by graphing, that's the solving by graphing. You have to put them in point slope formula and graph both lines. And the line should intersect at the point 7-11. You still have to put them in point slope formula and you still graph them the same way. I guess I'm trying to understand when you said you went over 7 and up 11, it should go off the graph, right?
Yeah.
Okay. And that's 1 point on both of the lines. So both lines should cross that point, but they should come away from that point differently, right?
Mm-hmm.
So how did you graph them?
It just kind of looks like a straight line where the 7 and the 11 is.
Well, you have to graph the lines just like you always did. In point slope formula. Just like I did. Well, how did you draw 2 lines?
Yes, but I was confused on like how to graph it.
It's just exactly like we've always graphed them. They're just going to intersect at the point 7-11. You don't change how we've graphed them. You still put them in point slope formula. You still use the y-intercept, and you still use the slope to draw each individual line. It's just that the 2 lines will cross each other at the point 7-11. Because that is the solution to the system of equations.
Okay.
Where the 2 lines intersect. But you'll still graph them the same way we always have.
Okay.
So you'll start by, but if you know, because you've already solved by substitution, if you know that the point at which they're going to intersect is going to be at the point 7-11, even though I know that my intersection point for this line, even though I know this right here, this line, actually it'll be this right here. My y-intercept is -3. It's way, way down here, right?
Mm-hmm.
I still use my y-intercept and my slope to make this line. Correct?
Mm-hmm.
So I didn't graph that any differently than we've been graphing all of the things so far. I used my y-intercept, which is -3, and I used my slope to draw my line. And I did the exact same thing here with this one. My y-intercept is 4, my slope was 1, and I drew it. But my point where they intersect is that 7-11, which is way, way out here. So those 2 lines cross there. Does that make sense?
I just don't know how to graph like the 2x minus y equals 3. That's where I'm most confused.
Okay, well, you put that in slope intercept form, which is this one right here. This is that same line in slope intercept form. Remember back when we were graphing at the first part of the chapter, you have to put it in slope intercept form, right? Remember that?
Yes, ma'am.
Right? So you would subtract 2x from both sides. Okay. That eliminates that. That gives you negative y equals negative 2x plus 3. And now I have to divide everything by a negative 1 because I can't have a y that's negative, right?
Mm-mm.
So that's 2x minus 3. So this is this formula in slope-intercept form, right?
Uh-huh.
Okay, so I graphed it using that.
Okay, that's making more sense. Thank you.
Uh-huh. And so the only thing that I did is then here is where it crosses the y-axis, but I used the slope to count it all the way up. But I just drew my line toward where I knew the intersection of the two lines should be. Does that make sense?
Uh-huh.
Okay. So that way my graph would make more sense with my substitution and my elimination. You don't change how you graph them. It's just you use the slope and the y-intercept to get you toward the line or the point where they should intersect. And the point where they intersect is the solution to the system of equation. It's an ordered pair where the two lines actually cross each other, where they meet.
Uh-huh.
And you can find them by graphing, and you can find them by elimination, and you can find them by substitution.
Uh-huh.
So have we done substitution on the? Yes, we did substitution. Did we do elimination? You did elimination, right?
On the page we just did?
Yes, ma'am.
Yes, I did.
So you've done substitution, you've done elimination, and we did the graphing.
Yes.
And we got the same answer for all of them.
Mm-hmm.
So that's what you do. All right, let's try this one. This actually turns out to be the same line. So we're going to do substitution first. So we got 3x minus 6y equals 12. And I've got to get one of my x's or y's all by itself. So I'm actually, so I'm going to take my 3x and subtract it from both sides. And that's going to leave me negative 6y minus 3x plus 12. And then I'm going to divide by 6, negative 6. And that's going to give me y equals positive 1/2 minus x minus 2. And then I'm going to substitute that in for y. 3x minus 6 times 1/2 x minus 2 equals 12. I'm going to distribute that 1/2. And negative 6 times 1/2 x gives me negative 3x. And 6 times a negative 2 is a positive 12 equals 12. The 3 x's cancel, and it's 12 equals 12, which is a true statement. So that tells me it's the same line, or infinite solutions is what you write. You can write same line or infinite solutions. Either way. And for the graphing on this one, oh, I erased that. Hang on just a second. Let me add y equals negative 1/2. Was it negative 1/2 x? No, it was a positive 1/2 x.
Yeah.
And it was a negative 2, right?
Uh-huh.
Okay. So that's in slope-intercept form. And then we're going to put the other one in slope-intercept form, and you'll see that they're the same line. And that's how you solve by graphing. So if I had 2x minus 4y equals 8, I'm subtracting 2x from both sides. So that would give me 2x plus 8. Then I'm going to divide everything by a negative 4, which would give me y equals 1/2 x minus 2. So it's the exact same line. And what that would look like graphed. What's my y-intercept on that, Lily?
Negative 2.
Yes, ma'am. Good job. And a positive 1/2 x says I'm going to go up 1, right 2. Up 1, right 2. Or down 1, left 2. Because I either go in one positive direction and one negative. One positive, one negative. I'm going to say it one more time. One positive, or one negative in order to get a positive. But here's that line, and it's the same line.
Yeah. So I don't have to graph like both equations because they're the same?
Yeah, because it would be the exact same because they both had the y-intercept of negative 2. So when it's the same line, you only graph the one. So elimination would look like this. I'm actually going to do elimination using both boxes because on this particular one, Lily, it would be 3x minus 6y equals 12, and then 2x minus 4y equals 8. And here, we're going to have to multiply. Look at that. The 3 on what you're going to have to do is figure out what can I multiply these by to get them to have the same coefficient on each of them. And this time you're going to have to multiply both equations by something. So how could I multiply these equations to eliminate one of the two variables?
Multiply the top one by 2 and the bottom one by 3.
Good job. Absolutely. So 2 times 3x is 6x, and 2 times a negative 6y is negative 12y, and 2 times 12 is 24. And 3 times 2x is 6x, and 3 times negative 4 is negative 12y, and 3 times 8 is 24. And you would subtract them, and that's going to give you 0 all the way across.
What about the negative 12y? Wouldn't that be... Oh, wait, no, if they're subtracted. Okay.
Yeah, good job.
So it would be no solution?
It's the same line. When it's a true statement, like 0 equals 0, it's the same line. Infinite solutions.
Uh-huh.
Infinite solutions. Many solutions, however you want to put it. Same line, infinite solutions, however you want to write that. Okay. This one, I'm going to use substitution because it's telling me y equals 3/4 x plus 1. So wherever there's a y, I'm going to plug that in. X minus 3/4 x plus 1 equals 1. Well, x minus 3/4 x is 1/4 x plus 1 equals 1. I'm going to subtract 1 from both sides. And that's going to give me 1/4. What did I do wrong? Oh, I forgot to distribute that negative. You usually catch me on that. Something didn't feel right. So plus 1. 1/4 x equals 2. And then if I, in order to divide both sides by 1/4, you're really multiplying both sides by 4. So it's x equals 8. And then you would substitute 8 back in, and you to that second equation, y equals, and I'm going to erase this. So I've got an x equals 8. 3/4 times 8 plus 1. Y equals 6 plus 1. Y equals 7. So my point is 8, 7.
Hey, Kelly, I'm just checking back in.
I'm sorry?
I was just coming back in to check on her. Hey, Phil, you go be with your family. She can. You think she can figure the rest of this out? I don't want you to spend all your time.
Well, I told her that I've already worked out 14, 15, 23, 24, and 25, or I'm about to work out 25 and actually take pictures. So I'll send her those.
Okay.
It's not the graphing
Okay.
part, but what I will try to do, I mean, if she's ready to be done, that's fine. And then she and I can pick up on it again tomorrow morning for a little while.
Yeah.
And then maybe she and I could even do this again Wednesday night.
Oh, that would be awesome.
So that she can get through this. She's catching lots of stuff. I feel like she knows what she's doing, but I think what I might do is maybe even in class, if she can bring this with her, so I can help her a little bit one-on-one with the graphing to make sure she's really getting that. Because if I could see her graph it, I think it would help me understand where she's getting a little confused.
Gotcha.
So even, you know, she wanted to do it Wednesday or Friday, either one. Actually, bring it Wednesday for sure, and let me have a chance to just talk to her a little bit while she does that. But we'll work some more of these out, and I'll send her the ones, because I'm already taking pictures of those worked out. So she'll see me work out substitution and elimination on about 5 or 6 more.
Okay.
And then she and I can work tomorrow morning, and then I can work with her a little bit on Wednesday, and then maybe we can. Do y'all go to church on Wednesday night?
No, we should be here Wednesday night, shouldn't we? Yeah, Wednesday night. We'll be here.
Okay, so I was going to say then she and I can maybe do 5 or 6 more.
That would be awesome. What time in the morning do you want her?
Well, I was thinking I was going to try to do regular math lab at 9:30. So I was thinking about trying to hop on with her about 30 minutes before, or we could do 30 minutes after, whichever one she wanted.
Well, your pick. You're helping us. We'll do it whenever you want.
Let me try beforehand.
Okay.
Because I just don't know how long math lab is going to run. I don't know if students are going to have questions because they're actually doing a quiz in the book, and I don't know if they'll have, you know, questions about it. And there's a quiz on Wednesday over this material. Okay. And if they don't really get it, I'll probably drop it to a daily grade, so it's not too bad.
Okay.
But anyway, so I'm thinking that I'd be better off doing a little bit of this beforehand.
Okay. Okay, I'll tell her I'll have her tune in at 9.
Okay. And
Okay.
I'll try and get it all set up so that it's a private Google Hangout like this was tonight.
Okay.
But if she, I think this is number 6, if she can try to go ahead and finish this one tonight, and then she and I could try to work through maybe 10 tomorrow.
Okay. That's awesome.
And then we'll try some more for Wednesday night, and then she'll have those others that I'm sending her pictures.
Okay. Thank you.
No
Thank
problem.
you so much, Miss Sparks.
Oh, no problem. Is it starting to make a little more sense?
Yes, ma'am.
Good, good. Graphing is really, I think the thing that I worry about is graphing is, believe it or not, is so important for really understanding geometry too. So I want to make sure that you're set up for that next year.
I don't want to take geometry.
Oh.
You'll be fine, Lily, I promise.
Well, thank you so much for your help.
No problem. Have a good night. Love you, ladies.
Love
Bye.
you.
Bye-bye.